So good morning, students. In the previous session, we have seen the distribution system. So it means the distribution of AC distribution system as well as of an DC distribution system. And we have categorized the DC distribution system and the AC distribution system. What are the categories of your AC and DC distribution system? And we have seen elaborately about the DC distribution system as well as of our AC distribution system, right? So we are coming to the last topic of our transmission and distribution. The last topic here is going to be of our fax devices. It means in our syllabus we will have the introduction to fax devices. That is the last topic in our transmission and distribution. It means the module 3 of last topic. What is we often fax devices? What is we often fax devices? Any idea? So here the content which we are going to see here is going to be today's session is going to be of our introduction, benefits of fax controller. In that, what about your shunt, what is the often series, and what is the often hybrid. This is just introduction to the topic. So I will ask you a question: what is the fax devices? It's an abbreviation. The fax FACTS is nothing but is the abbreviation. That is going to call us software. Flexible AC transmission system. Flexible AC transmission system. As we know that the power industry, it means our the generation transmission distribution. It means the power industry comes. But it's a develop, day by day it's developing and it's growing, growth rate is going to happen very high, right? So this why because the requirement of load is also high, and for the requirement of load, we need to supply the power. So it means the development and the growth in the power industry is going to happen rapidly increasing. Okay. So in that situation, the power transmission system, it should be highly stable. The power transmission system should be highly stable. How about what it means of this highly stable means nothing but in the maximum thermal limits of the transmission and as well as of the quality of our power. This is going to often supply to the consumer. Okay, so how this is going to often achieved? Since we know that most advanced technology has changed, it means the power electronics based devices are coming, right? Why can't we use that power electronics devices in our power system? Power electronics devices in our power system, so that we can able to achieve a good quality and reliability in our power system. So that we can able to achieve the good quality and reliability in our transmission system. Yes, but we are not speaking, but we know, I think we have categorized the power system of generation, transmission, and distribution. Okay, as a 3 section. Okay, so here, but the main important thing here is going to power transmission. Yes, but whatever the power is going to happen produced, that has to be transmitted to the local center where the power is going to happen needed. So while the transmission is going to play the vital part in the transmitting the power, so that has to be maintained with the quality and as well as their reliability. So for to achieve that quality and reliability in the transmission system with minimum investment, right? So we are trying to use the power electronic component in our power system. So that's nothing but that device. When we use the power electronics based technology in our power system, that here is going to call us of our fax. That is here is going to call us of your fax. It means flexible AC transmission system. That is going to call us of our flexible AC transmission. In the fax acronym is nothing but it's going to have our flexible AC transmission system. It means by using that technology which is evolving, right? So we can able to help our utility center. It means our industry, power industry, so that where nothing but the power delivery is going to have the main business going to have changes based on the requirement. So that's why here nothing but we are going for our power electronic devices. We are going for our power electronic devices. So that's why here nothing but here is shown here nothing but the concept of fax. It means F stands for flexible, alternating current transmission system. That is going to call the software fax. It means this is referred to our power electronics family of our power electronics which is going to be often able to enhance the AC system controllability and stability and to increase the power transfer capability. And it can able to increase the power transfer capability. I think we have studied in our circuit theory, in our electric circuit theory, we have studied about our maximum power transfer theorem. We have studied about our maximum power transfer theorem. It means the power transfer from source to load should be often maximum. When it will be often maximum? When our load resistance is equal to of your source resistance, then the power transfer from the source to load is going to be of your maximum. It means nothing but in power system also nothing but this whenever we'll call it often PV curve. PV curve. It means the PV curve. So the stability can be defined based on our PV curve, right? At an angle delta, when angle of delta is equal to often 90 degrees, the power transfer is going to be often maximum, right? So it means nothing but without loss of our stability, how we can able to transfer the power, maximum power to the load center. So that nothing but that can be achieved only with the help of our power electronics family, but our power electronics based devices that is going to call us of our flexible AC, means alternating current transmission system. Remember that is going to call us of your FACTS devices. Okay, so how it is going to be often defined? Remember, design means the design of our different scheme and the configuration. It means the various devices, FACTS devices, what we are going to see. Those devices, nothing but it's going to be often but with the combination of our basic power system components. Like we'll have the transformer will be there, we'll have the reactors will be there, we'll have the switches, and we'll have the capacitor. I think in our module 2, we have discussed about the methods of voltage control. We have discussed about the methods of voltage control. Correct? We have seen about the methods of voltage control. Like how to remember to improve the voltage, what are the devices we are going to use it to improve the voltages. We have discussed the methods of voltage control, like shunt reactor, series reactor, shunt capacitor, series capacitor, and we discussed about the synchronous generator. So this synchronous compensator. So using these devices, we can able to improve the voltage, right? Suppose if the line inductance is going to be often more, to suppress that one, we can add as often shunt capacitor. So that the reactor component is going to adjust so that the power quality is going to often get improved. So that we are seeing the help of our standard power system component. So if we use the same power system component, but with the help of our power electronics, component. So then that devices is going to call the software FACTS devices. It means we are going to use the transformer, the same transformer we are going to use. We are going to use the reactor, we are going to use the switches, or maybe a capacitor. But this is going to be a fan connected to the power system with the help of our power electronics devices. With the help of our power electronics devices. Okay. So neighbor, it means our either may using of your transistor or maybe of your thyristor. You can use of your transistor or it may be of our thyristor. So we can able to improve, but it means we can use this power electronics component so that we can achieve the stability in our power system, and we can have a good quality, and we can able to improve the transfer capability. It means to achieve the quality and reliability in our transmission system with minimum investment. It means with our minimum investment. I think we have seen, but I think this is going to offer sending end. So this is going to offer sending end. Sending end. So where the voltage is going to be often V1, and this is going to be often receiving end. So receiving end of the power system, right? Receiving end, right? And this is going to be our transmission line. This is going to be of our transmission line, and the receiving end point, the load is going to be often connected. Okay, as the load is not going to be often constant throughout the day, throughout the time period, so it's going to be often varying load. So load is not going to be often constant, it's not going to be often varying. So the transmission line has to be transmitted the power according to the requirement of the load. So how to transfer the maximum power without losing stability? So that if you want to make it up, means that we can able to make it with the help of our FACTS. So normally, so nothing but if you want to reduce the reactive power losses, so it depends upon the transmission line. Because the transmission line will have often nothing but but two important parameters going to be of our inductance and other one is going to be of our capacitance. So depends upon the transmission and conductors, this inductance and capacitance is going to be of get vary. If it's more reactive in our transmission line, then we can able to add the capacitance in the as a shunt element, so that will compensate our inductive reactance. So that but we are trying to match the impedance. Okay, if reactance part is equal to 0, the power transfer is going to be our maximum. So that but either we can connect our shunt capacitor permanently or it may be a switch. Okay, so this nothing but this can be done with the help of our power electronics devices. This can be done with the help of our power electronics devices. So based on that, we are going to classify what will be of our fax devices. So as I told, so what is the benefit of our fax devices? Kavin? Kavin? So what is the benefits of our fax devices? As I told, the power transfer capability of our transmission network. The power transfer capability of the transmission network, it will be increased. Okay, so if we use our fax devices, and we can able to control the power flow. We can able to control the power flow. It means nothing but as we know that the power transfer capability. It means the maximum power transfer from the source to load. Then only the system is going to be often reliable. Okay, so how to achieve the maximum transfer of power? So that's nothing but we can able to achieve with the help of our fax devices. With the help of our fax devices, it means to provide the direct control of the power flow over designated transmission routes, right? So it means the maximum power transfer theorem. Whatever you are studying in circuit theory, the same thing, the same maximum power transfer theorem. But we can apply here in our power system network also. It means each and every network, it has to be transferred the source, right? From source value should be often maximum value to source value should be transferred to the load. So how it is going to be often possible? That can be possible with the help of our fax devices. Okay, and third thing is going to often, but we can able to control the power flow. It means we can able to control the reactive power flow. If you able to control the reactive power flow, this automatically we can transfer the real maximum amount of real power to the system. Okay, so that the control of power flow as an order so that it follows the prescribed transmission corridor. So that we can able to achieve it with the help of our fax devices, and it can able to increase the loading capabilities of the line and to that thermal capabilities. Remember, the thermal limits will be as more amount of power is going to transfer, the heat produced will be often more in the conductor. So that how to maintain the conductor heat may be often important. So that can also be achieved with the help of our fax devices. Okay. So based on this, what are the various devices we can able to use with us? We can able to categorize the fax devices often. Shunt, series, as third is going to often combined. That is we are calling here is going to our hybrid. So we are classifying the fax devices as often three categories. Okay, one is going to our shunt. One is going to our shunt devices, fax shunt devices, and second thing is going to our series devices. Okay, and third thing is going to appear combined. So for third thing is going to our combined. So the combined that only here is going to have called as of our hybrid. That is going to have called as of your hybrid. Okay. So here that is the combined combination or combined here is going to have either series shunt or series or shunt series or shunt capacitor. Shunt fax device. So this thing is going to have called as of your combined or maybe as a combination of series and shunt. Combination of series and shunt. Okay, but when you're taking with respect of your shunt devices, when you're taking about your shunt devices, the first devices here is going to have our static war compensator. It is going to be called as of our static war compensator. So what is mean of this static war compensator? It's going to be called as of a static war compensator. It means nothing but that is nothing but the device. It means that the static war compensator normally that is going to call us of a SVC. That is going to call us of our SVC, static war compensator. It means the static war compensator is nothing but either it can able to generate or absorb. Okay, it means generate or absorb the war component. It means your reactive power component. Okay, so it depends upon the capacitive or inductive current. It basically depends upon the capacitive or inductive current. Okay, so that it can able to control or maintain the specific parameter in our power system. So that devices here is going to call us of our static war compensator. So the war here is nothing but volt ampere reactive. Okay, the war itself denotes your volt ampere reactive. Volt ampere reactive. It means the reactive power component. We can able to control the reactive power component. Either it can generate or absorb with the help of our accelerator. Then what about your static synchronous compensator? What about your static synchronous compensator? Nothing but that is going to call us of your SSC. That is going to call us of your SSC. That is going to call us of your SSC. Sometimes we can call us often STATCOM. Sometimes this can be also called as of your STATCOM. It means static but compensator. That is going to call us of your static compensator. So it means nothing but this is nothing but that is nothing but the synchronous generator. That is going to call us of your synchronous generator. Okay. That is going to call us of a synchronous generator. So if we control the excitation of our synchronous machine, then the synchronous machine we can operate as a generator or we can operate as a motor. With the help of the excitation, by the help of the excitation itself, we can operate the synchronous machine as a generator or motor. Okay. It means it can able to supply the reactive power or it can able to absorb the reactive power. If the synchronous machine is operating by controlling the excitation power as a generator, it means it can able to feed the reactive power. Okay. Suppose if you control the reactive but under excitation, if you're doing of an under excitation, that will act as of a motor. So during the under excitation, if the synchronous machine is going to operate as a motor, it means then it can absorb the reactive power component. It will be going to absorb the reactive power component. It means the compensator, whether it may be of an capacitive or inductive, based on the output current, it can be controlled independently. It can be controlled independently of your AC system voltage. So that devices here is going to be called as of a static synchronous compensator. That is going to be called as of a static synchronous compensator. So either you can call us of an SSC, it means double SC. So in the device name we can use of an SSC or you can use of an STATCOM. You can call us of a STATCOM. So these two devices that is going to be called as of a sun devices or a that is going to call us of a sun controller. That is going to call us of a sun controller. Okay. So when it comes with respect of a series fact controller, series controller, so thyristor controlled, we are calling of a thyristor controlled series compensator. That is going to call us of an TCSE. It is going to call us of a TCSE. So what it means of this TCSE? What it means? What is this means of the TCSE? So nothing but that is going to call us of a shortly you can call us of a thyristor switch capacitor. That is going to call us of a thyristor switch capacitor. It means it means thyristor controlled series capacitor, or you can call it often thyristor controlled series capacitor. It means that is going to call it of a TCSE. That TCSE means it will have often series capacitor banks will be there, and that will be centered with the thyristor controlled reactor. That will be centered with the thyristor controlled reactor, right? So it means this will provide smooth variable series capacitor reactor. It will provide the smooth variable series capacitance. Okay. That devices here is going to call us of a thyristor controlled series capacitor. That is going to be called as of a thyristor controlled series capacitor. Then next is going to be a static synchronous series compensator. Static synchronous series compensator. It means that we can use this often, but SSC, triple SC. That is going to be called as of a static synchronous series compensator. Okay, it means the synchronous generator will be operated without any external energy. Without any external energy, it means normally we'll power electronics will but the conduction mode will be but 4 quadrant mode of operations will be there. First quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so when you take here with respect of the so here is the quadratic. Here is going to appear quadratic, and it can be controllable independently of your line current. It means your voltage will be of your quadrature, okay, and you can be able to controllable independently with your line current. Okay, so it means the purpose of what is the purpose of using our synchronous series compensator here is nothing but it can able to increase or decrease our overall reactive voltage drop. Increase or decrease the overall reactive voltage drop, so that we can able to control our electric power which is going to be often transmitted. So it means our static synchronous series compensator, triple SC, right, which is going to be includes one energy storage devices, or it may be of an energy absorbing devices. When it is going to often but energy storage device act means depends during on your transient periods. So then I think we are going to classify our stability of the system. The stability is going to be very, very important when you are transferring the power to the source to load. So we are trying to transfer the power to maximum power. We are going to transfer it. When you are transferring the maximum power, the stability is going to happen very, very important. So to maintain the stability, so when the disturbance means there may be often the disturbance may be of a small, or maybe of a large, or maybe of a medium. Okay, so when the disturbance will be caused in the system, the disturbance here is either maybe of change in load, or maybe of a fault, or whatever it may be, or switching. So whatever it may be, so remember that behavior here is going to assume the transient that here is going to assume the stability transient. So that here is going to call us a dynamic behavior. Okay, so when the dynamic behavior of the power system during the transient period, the dynamic period. So if you want to increase the stability, means then we use our static series compensator. So that will increase your dynamic stability. That will increase your dynamic stability. It means using with the help of our energy storing devices or energy absorbing devices, we can improve the stability of the system. Okay, so that is here is going to call us of a static synchronous series compensator. That is going to call us of our static synchronous series compensator. Okay, so with the help of that, we'll have a fault current limiter. It means SC, switching capacitor, and fault protection will be there. So that we are going to see in schematic. Okay, so in the hybrid means the hybrid here is going to often combination. It may be of a series, or series shunt, or maybe of a shunt series, or it may be of a shunt compensator. Okay, so it means that here is going to often will call us often dynamic power flow controller. Okay, another one is going to call us often UPFC, Unified Power Flow Controller. That is going to call us of your Unified Power Flow Controller. So that here is going to call us of your hybrid. That is here is going to call us of your hybrid. Okay, so we'll see one by one. What is your shunt? What is the often series? Okay, shunt. So here, for easy understanding, okay, so this is the examples. These are examples of our shunt compensation. So it means our side to but see here. See here. So we are having of this reactor, and we are having of your capacitor. So So in the module 2, in the methods of voltage control, we have seen nothing but, we can connect the reactor permanently in our system, or it will be of a switching. So it will be of our switched reactor. It will be of our switched reactor. Okay. So but to increase the stability and power transfer capability and quality of the power, so we are adding the power electronics component in the power system. We are adding the power electronics component in the power system. So with the help of the power electronics component, we can achieve the most stability in our power system. So that is nothing but if you connect to a reactor, it means thyristor controlled reactor or thyristor switched reactor or thyristor switched capacitor. Okay. Here, the shunt compensation. So with the help of our power electronics, we are going to connect the capacitor. So here but it will here what will happen is but using that we can able to control the current source. We can able to control the current source. So shunt compensation here is going to have a shunt capacitor, or it may be of a shunt inductive. It will be of a shunt capacitor or maybe of a shunt inductive compensation. When it comes with respect of your capacitive compensation, when it comes with respect of your capacitive compensation, what is mean of the capacitive compensation? This will be of the transmission line, and we have this is going to our transformer. This symbol denotes our transformer. Okay, and I am going to connect my capacitor. How I am going to connect the capacitor? Means I am going to connect the capacitor with the help of our power electronics devices. With the help of my power electronics devices. Okay, I am using the thyristor. I am using the thyristor. Okay, I am using my thyristor. I am connecting my capacitor. I am connecting my capacitor. Okay, so if I control the gate, remember thyristor gate first. If I control the thyristor gate first, what will happen? The current injected by the capacitor, the current injected by the capacitor in the transmission line. This is going to be of our transmission line. This is going to be of our transmission line. So that will be controlled. It means with the help of the gate pulse of the thyristor, okay, I can able to control the current injected in the transmission line of the capacitor. Okay, so that's why here remember the controllable current source. It works as a controllable current source. Okay, the shunt current controllers is nothing but which is going to act as a controllable current source. So it means what is the purpose of this capacitor? It will improve the power factor. It will improve the power factor. It means whenever the inductive load is connected to the transmission, the power factor normally is going to happen lag. Okay, why? Because due to of the lagging current. In the inductive, current is going to happen lag the voltage by an angle. Current is lag the voltage by an angle. It means you are phi. Okay, so this is your reference voltage and this is going to affect current. Only in the purely inductive circuits, whenever current lags the voltage by angle of 90 degrees. Current lags the voltage by 90 degrees. Okay, so we here in the power system we cannot able to say that it's going to happen purely inductive. It's going to happen resistive inductive. It may be of your resistive inductive. So that's why here I am telling you the current lags the voltage by an angle of phi. Okay, so normally whenever the inductive load is going to happen connected in the power system, so the power factor will be lag. So because of your lagging load current, so that lagging component can be compensated by adding the shunt capacitor. So that it will that will draw the leading current component in the source voltage. Okay, so that we can able to improve the power factor. So it means how much amount of current has to be injected in the transmission line by the capacitor will be decided by our power electronics component, and remember that is going to call us of our thyristor. If you control the gate pulse, then automatically you can able to control the current injected by the capacitor in your transmission. But in the previous session, what we have seen in the module 2 is the methods of voltage control. Your capacitor, either the shunt capacitance will be connected permanently in the transmission line, or it will be of a switched capacitance, or it will be of a switched capacitance. It means when it's permanently connected, means it always inject the current. It is always inject the current. When it's going to have a switch, so whenever the switch is going to have a close, the capacitive current is going to have added in the transmission line. Okay, but it won't but control the reactive component as when it's needed. It means how much is going to have needed, that can be that much amount of capacitive current only injected. So that will be injected only in your fact devices, not on the ordinary shunt capacitor or series capacitor. Shunt capacitor or series capacitor. So here, instead of capacitor, if I replace that one by using your inductive reactance, okay. So then that is going to be called as of your shunt inductive compensation. That is going to be called as of your shunt inductive compensation. Okay. So when there is often low load or no load, what will happen? I think we have seen about the parentic effect in our transmission. Module 2, we have discussed about the parentic effect. It means compared to the sending end voltage, your receiving end voltage will be more. So when it will be more, when you are in the, but you are under the light load condition or no load condition. So what will happen? Your sending end voltage will be more compared to the receiving voltage will be more compared to your sending end voltage. Okay. So during that time of period, but I want to maintain the voltage as often constant at the time also. So that can be achieved with the help of my shunt inductive compensation. Okay, it means due to often very low or no load, the very low current flows to the transmission line. So automatically, what will happen? My sending end voltage will be less compared to of your receiving end. It means the receiving end voltage will be often more. So that is where here is going to call us of your parentic effect. Okay. So that can be compensated with the help of our shunt inductors, which is going to be often connected across your transmission line. It means I am having a transmission line. I will have of my transmission line. I will having a transmission. This is going to be of my transmission line. Okay. So this will be having a transmission line. I will have a transformer. The fact devices can be connected directly, or you can connect with the help of the transformer. That's not a problem. Okay, you can connect because the thyristor will be taking care to control your current injection or current absorption. So here I will use my power electronics component, right? So that is going to of my thyristor. Okay. So here I will have open inductive reactance. Okay, the current which is going to happen, the inductive current which is going to happen added in the transmission line, it depends upon the reactance in your transmission line. Okay, so this devices is going to appear shunt device. This devices here is going to appear shunt devices. See here, so I can add often TCR, or I can add often TSR, or TSC, or MSC. Okay, or STATCOM, static synchronous compensators. Okay, so this is some of the examples of our shunt compensation. These are some of the examples of our shunt compensation. Okay. So what is my SVC? SVC is nothing but I have told you is static var compensator that is going to call the software SVC. So is nothing but the dynamic voltage regulator. SVC here is going to call the software dynamic voltage regulator. It means DVR, dynamic voltage regulator. It will increase the efficiency in our power system. It will control the voltage so that it can able to increase the efficiency in our power system. Okay. So most common used SVC that is going to offer thyristor controlled reactor. It means the reactor will be connected in series with the bidirectional thyristor valve. Okay. The valve is, it means the gate is going to happen. Thyristor gate is going to happen controlled by phase control method. That will be controlled by phase control method. Okay, or it may be as a thyristor switch reactor that is going to be called as software TSR. Okay, it means either in zero or full conduction mode it will be operating. So but it will be often equivalent reactance will be varied in a stepwise manner in case of a TSR. Okay, So when it comes with respect of a thyristor switched capacitor, that is going to be called as often TSC. Okay, capacitor is going to be often connected in series with the bidirection. Okay, this is also either in zero or full conduction mode. So it's going, this is also the equivalent reactance here is going to often vary in the stepwise manner. Okay, so next is going to be often mechanically switched capacitor that is going to be called as often MSC. So capacitor will be switched by our circuit breaker. So it means compensating your steady state power, reactive power. Okay. So it means only for few times only a day it's going to often switched off. Remaining time it will be of switched off. Okay. So that is going to be called as of mechanical switched capacitor. So what about your series connected controller? Series connected controller of FACS devices. Any doubt? So FACS devices here is going to offer but series controlled controllers here is but FACS device is going to offer there is a controlled series capacitor that is going to call us often TCSC. It means the series capacitor will be centered by our thyristor controlled reactor. Or thyristor controlled series reactor that is going to call us often TCSR. It's a series reactor fan centered by thyristor controlled reactor. Okay. Or TSSC. It means thyristor switched series capacitor. It means the series capacitor bank will be centered by our thyristor switch reactor, or it will be upon TSSR, thyristor switch series reactor. Okay, so what it means? See here. So here in the we have the line reactance. This reactance, remember TCSR or TSSR. This is going to our thyristor controlled switch reactor or thyristor switch series reactance. Okay. TCSC or TSSC. So it can operate in both the things. So this is going to our hybrid controller. This is going to call us up here hybrid controller. It means the hybrid controller will have a shunt and series controller. It means that we are controlling the support. I think I have told you here nothing but in the previous thing I have told you nothing but I can but the transmission line is going to sorry. So this is my transmission line. So this is my line. Okay. So I'm using the transformer to connect my FACS devices. I'm using the transformer to connect my FACS devices. The FACS devices here is going to be often connected with the help of my thyristor. So remember, with the help of my thyristor. Okay. So here I'm connecting either a capacitor or reactor I'm going to connect it to. So it means but it will control, suppose if I connect the capacitor means nothing but leading component of current only is going to be often added. Okay. So sometimes the circuit may lead, suppose the same transmission line, at the receiving end, if the load connected is going to be often gradually reduced or it will lead to often very less load. So automatically what will happen? The receiving end voltage will be more compared to our sending end voltage. So at the time what I need? I need only of the capacitance. Okay, I need of a capacitance. But where the capacitance is going to be often needed, so that is going to be needed in the series. That is needed in the series. So if I want the same line, if I want to control the shunt and the series, it means I have to adjust the shunt reactance as well as of my series reactance. Then I am going to add the power electronics component in the shunt as well as of my series. Okay. So automatically what will happen? I can enable using DC power link, I can able to control the valve in a combined manner. So that is going to call us as a hybrid controller. That is going to call us as a hybrid controller. That is going to be called as your hybrid controller. Okay. So here you have to know about each and everything. Suppose if I use the series capacitor, what is going to often control? It will control only the impedance. Suppose I'm using often shunt capacitors, it means our shunt reactors or load changing transformer or synchronous phase modifier means it will control only the voltages. It will control only the voltages. Why? Because you have to know what is the conventional equipments are available in our power system. Then how the conventional equipment can be enhanced the power system control with the help of our fact devices. With the help of our fact devices. I think the conventional element here and what I am trying to tell is nothing but like series capacitors, shunt reactors, series reactors, transformer. So these are all the devices which will be used for methods of voltage control. So what each and every equipment is going to often control the parameter in our power system. Suppose if we use a series capacitor that will controls only the impedance. Suppose we are using a shunt capacitor or shunt reactor or load changing transformer equipment or synchronous phase modifier, so that will only control the voltage in our power system. Suppose if you use the phase shifting transformer, so that will control the angle. Okay. Suppose if you use a stability controller, so that will focus only the voltage, but that will be there controlled only in the power. Okay. So suppose if I am using the stack devices, assume it is going to have a static war compensator. Assume it is going to have a static war compensator. So that will act as a control parameter on the voltage control. Will control the volt ampere reactive. It means your reactive component, damping oscillation, transient and stability, dynamic stability, and voltage stability. So these parameters will be controlled with the help of our static war compensator. Suppose if you are using a StatCom, it means static synchronous compensator. That is going to call us our StatCom. If you are using the StatCom without energy storage or with energy storage, what will happen? What are the parameters going to control? It will control the voltage. Suppose if you are not using this without storage devices, if you are using a StatCom, it will control only the voltages, war compensation, and voltage stability. But if you use your static synchronous compensator with the storage means it can also act as an automatic generation control also and improve the damping oscillation along with your voltage control and war compensation. So likewise, each and every PAX devices or PAX controller will has its own controlled parameter. It has its own controlled parameter. Okay. So based on that only, but we can able to say that how about your hybrid, so shunt and series controller, or remember that is going to be called as a unified power flow controller. It means it will control the current, voltage, impedance, and the power. So that fourth quadrant that is going to share is going to be called as software unified power flow controller. Okay. So this is here the last topic is only of an introduction only. It's introduction to various devices. Okay. So we have seen about what is the fact, what is the acronym of your fact. Okay. So what is the main role of our fact devices we have seen. Okay. How to employ the fact devices in our power system we have seen, and what is going to control, what are the parameters going to control in our power system. Okay. So this is all about our fact devices. So this makes our completion of our syllabus. So remember that one, the main benefit of the fact devices limit, one is going to have our stability, second thing is going to have loading capability, third is going to have our security and reliability. Okay. And if we use these fact devices without need of any additional transmission, we can able to increase the power transfer capability. Flexibilities will be there for our new generations. Okay. So any doubt? Any doubt? Okay, Hariharan. No, sir. So yes, Wednesday we'll have a fun. UT3 will be there. Okay. So then, but you can able to practice more for your CA3 as well as of your end semester examination. So for that, so on Wednesday you will have a fun. UT3 will be there. Okay. So where you will have a fun 30 questions will be there. 1.5 hour time period will be there, and you have to answer that question. Okay. So for practicing that one, now just for understanding yourself, how the questions will be there, just for some sample discussion. So I will take some of the questions from here. Okay. I think my question is visible. Students, whether my slide is visible? Okay, yes, sir. Okay. So which type of insulator is used on 132 kilovolt transmission line? Pin type, disc type, shackle type, or pin and shackle type will be used. Which type of insulator is used on the 132 kilovolt transmission line? So I think in the insulator, module 3, first topic we have seen about the insulator, correct? The module 3, first topic we have seen about the insulator. Okay. So I think we have seen about our pin insulator, suspension type of insulator, shackle insulator, and stay insulators. We have discussed about four different types of insulator. Okay. So here they are asking which type of insulator is used on 132 kilovolt transmission lines. What is the answer? What is the answer? Disc type by Ruben. Only one answer. Pin type by Suganathan. Unless you type A, B, C, which option? Type the option in your chat box. Disc type by Abhirami. Type your options in the chat box. So disc type or suspension type, both the meanings are same. Here in the question is I have but instead of asking the suspension type, because in the theoretical classes we have seen about but pin type insulator, suspension type of insulator, stay insulator, and shackle insulator. Okay. So here the suspension type, the suspension type is going to occur disc type. So I think we have drawn like this. Okay, the diagram we have drawn like this. The disc type. Okay, so this is going to occur disc type. This will have a disc type of insulator. So if it for often 130 kilovolts, we'll use often disc type of insulator. Answer is going to occur D. That is the correct answer. Okay, so pin type of insulator will be normally used in your primary distribution and secondary distribution. Primary as well as of our secondary distribution. Okay. Disc. So only few people are in the online, I think so. So next question. What is the dielectric strength of the porcelain? So I think in the theoretical class of our insulators, we have seen about what are the materials will be used for the making of our insulators. We have discussed the various materials. We have discussed about the various materials. Okay, either you can use often glass, often insulators, right? Like this we have seen. Okay, so how we are going to produce this? I think remember the process will use of our devices here is going of our process. So normal measurement insulator will use of our process. So process is going to often consist of what are the materials? What are the materials? Corulon, feed, feldspar, Quatrax, all these things will be there. That combinations will be, but the mixtures of all these things at high temperature only, we are going to produce the porcelain. Why we are producing the porcelain? So it will have often high dielectric strength. It will have often high dielectric strength. Okay. So what will be of the dielectric strength? What will be of the dielectric strength of the porcelain? What is the answer? What is the dielectric strength of the porcelain? B. Yeah, it's a 60 kilovolt per centimeter. 60 kilovolt per centimeter. So here you see that in the question whether the unit is going to be of here 60 kilovolt per centimeter. If it meter, then the value is going to be of different. Okay, so B is your correct answer. B is the correct answer. So B is the correct answer for this question. Come on. The third question here. The number of discs in a string of insulators for 400 kilovolt AC overhead transmission line lies in the range of A. How? Sugunathan, how? Rupan, you have mentioned as often B. How? Just unmute and tell the answer how. Whether it's right or wrong, that's not a problem. I will explain. Rupan? Ruben? 130 Ruben? I think he's left the meeting. If you ask any question, if you ask anyone to unmute, they will leave the meeting. Any idea by anyone? Yes, Ruben. Ruben? Okay. So how you are telling B is the answer?
யூனிட் டெஸ்ட் எழுதின மாதிரி இருந்துச்சு சார், அதை சொன்னேன்.
யூனிட் டெஸ்ட் எழுதின மாதிரி இருந்துச்சு, அதை வச்சு சொல்றீங்களா? ஓகே. So I will tell you. when we see the suspension type of insulator, okay, the suspension type of insulator that is going to call us of your disc insulator. Okay, so normally for each disc voltage rating is going to be of your 11 kilovolt. Each disc rating is going to be of your 11 kilovolt rating. Okay, each device's voltage rating is going to be of your 11 kilovolt. Okay, so when it's going to have 11 kilovolt, only but 11 kilovolt. Each disc means the maximum limit, the capacity of the disc which is produced, the disc insulator. I'm talking about the suspension type of insulator. That is going to have a disc insulator. So then that disc insulators, okay, each disc having a voltage rating capacity of 11 kilovolt. Suppose if we having a 400 kilovolt transmission line, how many discs will be there? 400 divided by 11. How much you are getting? How much you are getting?
Sir, 36 something.
30?
36, sir.
36. But in the question, I have not given any 36 value, no? Actually, I told you in the power system, each and every calculation we are doing for per phase. It means this voltage is going to be your line voltage. This is your line voltage. Okay. So normally, number of discs required, N will be equal to often, but the operating voltages. We used to call that is going to call us your operating voltage. That is going to call us your operating voltages. So operating voltage per phase, operating voltage per phase divided by voltage rating of the disc. So I told you in the theory class, each disc has the capacity of 11 kilovolt. Okay, so that is nothing but capacity of each disc. It is 11. It means 400 is the line voltage. I want a phase voltage. What do I have to do? I have to divide it by root 3. I have to divide it by root 3. Okay, so then that value I have to divide it by 11. How much you are getting?
20, sir.
20.9. 20.9. So normally this, if you get the values of 20.9, so this will be approximately to of the nearest value. It is 21 disc. Okay, it will be often 21 disc. So here, keeping in the mind the safety because sometimes we cannot able to transmit the same 400 voltage per motor. There will be a plus or minus voltage will be here. So for safety purpose, one insulated disc will be increased. Okay, so it means the number of discs here is going to be nothing but N will be equal to often what you are calculating plus that is equal to often plus 1 you have to add for safety. For the safety of the insulator, we will have often additional 1 disc will be there. So it means your value will be equal to often 21 plus 1, that is equal to of here 22. It means 22 discs is needed for 400 kilowatt transmission line. So then only your answer will be of your D. Now you got it? Within 15 seconds you can able to give. If you understood the concept, you can able to give within a 15 seconds, you can give the answer for this question. So no much there calculation. Okay, so this type of questions will be there. So this type of question also will be there in your MCQ. Okay. Any doubt in this question? Yarko Priya?
Sir, row 3 எதுக்கு யூஸ் பண்றோம் திருப்பி சொல்லுங்க சார்.
அதாவது பார்த்தீங்கன்னா இங்க கொடுத்திருக்க வோல்டேஜ் வந்து பார்த்தீங்கன்னா லைன் வோல்டேஜ் 400 அல்லது 135 இப்படி சொல்றது 134 135 சொல்றது எல்லாமே பார்த்தீங்கன்னா லைன் வோல்டேஜஸ். ஓகேங்களா, நம்ம கால்குலேஷன்ல போட்டது வந்து பார்த்தீங்கன்னா ஒரு ஃபேஸ்க்கு வந்து பார்த்தீங்கன்னா என்ன இருக்கும், டிஸ்க் வோல்டேஜ் எவ்வளோ இருக்கும், இல்லை சிங்கப் எப்படி இருக்குன்னு சொல்லி பர் ஃபேஸ் ஈக்குவல் தான் போட்டு ட்ரா பண்ணுவோம். ஓகேங்களா, ஸோ அப்போ ஒரு டிஸ்க்ல வந்து ஒரு சஸ்பென்ஷன் இன்சுலேட்டர் எடுக்கிறோம்னா ஒரு சஸ்பென்ஷன் இன்சுலேட்டர் 5 டிஸ்க் 6 டிஸ்க் இருக்கும். அப்போ ஒரு டிஸ்கோட கெப்பாசிட்டி வந்து பார்த்தீங்கன்னா பார்த்தீங்கன்னா 11 கிலோவாட். அப்போ அது ஒரு ஃபேஸ்க்கு தானே சொல்றோம். அப்போ கொடுக்குற வேல்யூ வந்து பார்த்தீங்கன்னா யூ ஹேவ் டு கன்வெர்ட் திஸ் இன்டு, பட் கொடுக்குற வோல்டேஜ் வந்து பார்த்தீங்கன்னா லைன் வோல்டேஜ் கொடுத்துருப்பாங்க. அதை வந்து ஃபேஸ் வோல்டேஜை கன்வெர்ட் பண்ணிட்டு அதுக்கப்புறம் ஒரு டிஸ்கோட மேக்ஸிமம் கெப்பாசிட்டி வோல்டேஜ் வந்து பார்த்தீங்கன்னா 11. ஓகே, தென் யூ ஹேவ் டு கால்குலேட். ஸோ இந்த பேட்டர்ல வந்து பார்த்தீங்கன்னா நிறைய வித்தியாசமா கேட்கலாம். ஸோ அப்போ 66 கிலோவோல்ட் லைன் இருக்குது. அப்போ அந்த 66 கிலோவோல்ட்ல வாட் இஸ் தி நம்பர் ஆஃப் இன்சுலேட்டர் டிஸ்க் இஸ் நீடட். சம்டைம்ஸ் அந்த கொஸ்டின்ல கொடுக்கலாம், if the insulator disk of each 11 kilovolts are used, what will be the number of insulator disk? ஓகே, புரிஞ்சுதா? இங்க கொடுத்திருக்கிறது வந்து பாத்தீங்கன்னா இது லைன் டு லைன் வோல்டேஜ், இது லைன் டு லைன் வோல்டேஜ், ஃபேஸ் வோல்டேஜ் கிடையாது. ஃபேஸ் வோல்டேஜ் வந்து வேணும்னா லைன் வோல்டேஜ் வந்து பாத்தீங்கன்னா you have to convert divided line voltage divided by √3, you will get your phase voltage. You know, in your circuit theory, you have studied about your relations between the phase and line. It means phase voltage, line voltage, phase current, another line current. You did the but under balance condition you have derived the derivation for your relationship between the phase voltage and line voltages and phase current and your line current. So that number that will be used in our power system calculation. So normally in our power system, entire analysis will be carried out on the per phase analysis. So that is applicable for your all the three phases. So the voltage here is given, normally if you given like this means that will be of your line voltages. Okay. So, but calculation we used to have often per phase. So that's why they are dividing that value by √3, so that this is going to have to convert into often phase voltage. Got it?
Yes, sir.
Okay. Yeah, we'll move to the next question. So what is the desirable safety factor prescribed for the pin type of insulator? What is the desirable safety factor prescribed for the pin type of insulator? If you have understood the concept very clearly, then only you can be able to answer for this question. Why? Because it is the safety factor we have seen when I am explaining the pin type of insulator, I have explained about the what is in this flashover and what is about my puncture. Flashover is what is the flashover in the insulator and puncture of the insulator. So there I have explained the safety factor for your pin type of insulator. Yes, Gunadhan is correct. So now we can able to Google it and you can able to answer. So, but in your examination and CA3, the platform of conduction will be ANCAD. Okay, you cannot able to browse or you cannot use anything. Okay. So if you thorough in your theoretical concept alone, then only you can able to answer your MCQ question. So answer here is going to appear C. It means 10. It means that the safety factor here is going to appear 10. Okay. So next question. Why is the voltage rating of a multiple cell pin type of insulator cannot be increased behind a limiting value? Why is the voltage? Because shell pin is but I think I have shown different diagram for your pin insulator. Okay, so one single insulator you can use, or like two or three different types of shape will be there in a single pin. Okay, so that will call the often multiple cell pin insulator. That multiple cell pin type of insulator we cannot use it behind some value. Why? Why we cannot able to use that one? I think we have seen about the safety factor. Safety factor, what is the meaning of the safety factor? So, safety factor is nothing but puncture strength by flashover voltage, that is going to be called as of your safety factor. Puncture by flashover. It means puncture strength by flashover voltage, that is going to be called as of your safety factor. Okay. So based on that only we have calculated what is the safety factor of our pin type of insulator. Okay. So why we cannot use the multiple cell pin type of insulator behind certain value. Here, due to the uneven voltages, answer here is the answer for this question here is going to appear A. A choice is the correct answer for this question. It means the internal voltage distribution between the cell become unequal. Why? Because if you see the pin type of insulator, so normally if you take up a pin type of insulators, the pin type of insulators will be like this one. Single pin will be there. Okay, there will be often groove will be there. Over that you have often groove will be there. So that groove is going to be often carrying the conductor. This will be a pin type of insulator. Okay, so if you use the same pin type of insulator like small disc, disc so you will have often pin. So you will have often groove will be there on this one. So here the unequal voltages will be there. You current able to call us of this. So this will be called as of this. This is going to be called as of this. So each and every disc we can able to connect. Sorry, the diagram I am drawing is not exactly the okay. This is going to call us of multiple cell pin type of insulator. This is going to appear multiple cell pin type of insulator. In the multiple cell type of insulators, right, the internal voltage distribution will be unequal. Okay, suppose if I use this disc type of insulation, each and every disc will have the capacity of 11 kilovolts. So the distribution of voltage will be of your same in the disc type of insulator. Then disc type of insulator in the disc will be same voltage ready, but here uneven voltages will be there. So that's why we cannot use the pin type of insulator behind certain voltages. It means maximum we can use for often 11 kilovolts, or in worst cases, this multi-cell pins we can use for often up to often 22 kilovolts. So behind that we cannot able to use it. So this pin type we can use up to often maximum of 11 kilovolts. This type of multi-cell pin type we can use for often 11. Sometimes rarely we use the often 22, but 22 it cannot able to withstand. There will be a frequent puncture will be happen. Okay, so that is due to of the internal voltage distribution between the cells become unequal. So answer here is going to appear A. Okay, so any doubt in this question? Any doubt in this question? Okay. Sorry. Okay. Next, sixth question. Each line of three-phase system is suspended by a string of three similar insulators. If the voltage across the line unit is 17.5 kilovolts, calculate the line to neutral voltage. Assume the shunt capacitance between each insulator and the earth is 1/8 of the capacitance of the insulator itself. Line to neutral voltage. So normally how we will draw the diagram? Insulator diagram voltage we will draw the insulator diagram. You can say draw tower. This is going to our tower, and this is going to our cross arm. So this is going to our cross arm. So which is going to upon hand but located on our insulator. Okay. Here each line of a three-phase system is suspended by a string of three similar insulators. Suspended by a three similar insulator, each insulator will be represented as often shunt capacitance. So 1, 2 and 3. And this is the point where the conductor is going to hang. Okay. So here they asked to calculate the line to neutral voltage. The line to neutral voltage calculate. Okay. Next, assume that the shunt capacitance. Shunt capacitance there. Cover to the pin, but pin that is going to call us after. Also, this is the capacitance. So this capacitance is going to call us after shunt capacitance. This is going to call us after shunt capacitance. This is shunt capacitance. I think we have solved this type of problem in our theoretical class, in our session. Correct? The problem the type of problem Anyone unmute and tell me whether we have seen this type of problem in the theoretical? That was a good window. No, sir. Insulator number distribution of voltages. We have taken the what is the voltage in each and every string. String efficiency calculate pannama. String efficiency calculate pannama இல்லையா? மறந்துட்டீங்க. ஸ்ட்ரிங் எஃபிஷியன்சி வந்து நம்ம கால்குலேட் பண்ணியிருக்கோம். ஓகேங்களா? ஸ்ட்ரிங் எஃபிஷியன்சி வந்து கால்குலேட் பண்ணியிருக்கோம். நம்ம ஃபர்ஸ்ட் ப்ராப்ளமே வந்து பார்த்து எப்படி பார்த்தோம்னா வந்து பார்த்தீங்கன்னா ஈச் டிஸ்க் வந்து 11% இருக்குது. அப்படின்னா கே வந்து பார்த்தீங்கன்னா வாட் இஸ் த கே வேல்யூ? But ratio between the self capacitance to the shunt capacitance to the self capacitance, that is going to call us after K. அதுதான் வந்து நம்ம போட்டோம். அப்படிதான் நம்ம போட்டோம். போட்டோமா இல்லையா? இது வந்து பாத்தீங்கன்னா சி கெப்பாசிட்டன்ஸ் சி இதுதான் வந்து பாத்தீங்கன்னா சன் கெப்பாசிட்டன்ஸ். இது வந்து பாத்தீங்கன்னா சன் கெப்பாசிட்டன்ஸ். இந்த சன் கெப்பாசிட்டன்ஸ் வந்து பாத்தீங்கன்னா 1/8 of the capacitance of the insulator. It means but K என்ன பார்த்தோம்? K is equal to nothing but shunt capacitance. K is going to have your shunt capacitance by self capacitance. That is going to have your ratio. It means this is going to have your Kc. This is going to call us after Kc. இது எடுத்துருந்தோம். இது வந்து பாத்தீங்கன்னா இந்த ஜங்ஷன் பாயிண்ட் வந்து பாத்தீங்கன்னா A, இந்த ஜங்ஷன் பாயிண்ட் வந்து பாத்தீங்கன்னா B, அண்ட் இந்த ஜங்ஷன் பாயிண்ட் பாத்தீங்கன்னா C போட்டிருந்தோம். இதுக்கான வோல்டேஜ் என்ன பண்ணியிருந்தோம்? இது வந்து பாத்தீங்கன்னா P1. இதோட வோல்டேஜ் வந்து பாத்தீங்கன்னா between this one this voltage is going to have your V2 voltages. இதோட வோல்டேஜ் வந்து பாத்தீங்கன்னா V2 voltages. Then இதுக்கு between this வந்து பாத்தீங்கன்னா it's going to have your V3 voltages. பண்ணமா at node A what we did at node A or junction by applying Kirchhoff's current law பண்ணமா இல்லையா? Kirchhoff's current law at junction A, entering current is equal to of your leaving current. Entering current is equal to of your leaving current. பண்ணமா இல்லையா? இது வந்து பாத்தீங்கன்னா இது வந்து I1 கரண்ட் எடுத்தோம். இது கேபிட்டல் I1 எடுத்திருந்தோம். இது வந்து பாத்தீங்கன்னா ஸ்மால் I1 எடுத்திருந்தோம். ஸ்மால் I1 எடுத்திருந்தோம். இது வந்து பாத்தீங்கன்னா I2 கரண்ட். இது வந்து I2 கரண்ட். இது வந்து ஸ்மால் I2. இது வந்து பாத்தீங்கன்னா ஸ்மால் I2. தென் இது வந்து பாத்தீங்கன்னா I3 கேபிட்டல் I3. இது வந்து பாத்தீங்கன்னா small I3 at node A. at node A or at junction A, applying Kirchhoff's current law, KCL law, entering current is equal to your leaving current. இங்க வந்து பார்த்தீங்கன்னா கெப்பாசிட்டன்ஸ் கொடுத்துருக்காங்க. அப்போ கெப்பாசிட்டன்ஸ் என்ன பண்ணோம், ரியாக்டன்ஸாக மாற்றுறது, கரண்ட் இன்ட்டு ரியாக்டன்ஸ் வோல்டேஜாக இருக்கும். ஸோ அப்போ அதுக்காக நம்ம என்ன பண்ணோம்னா, நம்ம வந்து பார்த்தீங்கன்னா ரியாக்டன்ஸ் வந்து 1/ω. இட் மீன்ஸ் யுவர் எக்ஸி வில் பி ஈக்குவல் டு ஆஃபன் அப்படின்னு சொல்லி நம்ம கால்குலேட் பண்ணோம் கரண்டோட வேல்யூக்கு. அந்த கான்செப்ட் தான் நம்ம இங்கே அப்ளை பண்ண போகிறோம். ஓகே, இப்போ என்னன்னா I2 கரண்ட் அட் ஜங்ஷன் ஏல பார்த்தீங்கன்னா என்ட்ரிங் கரண்ட் வந்து I2 கரண்ட், லீவிங் கரண்ட் வந்து பார்த்தீங்கன்னா கேபிட்டல் I1 பிளஸ் ஸ்மால் I1. யூ கேன் ரைட் வாட் அபவுட் யுவர் வோல்டேஜ். நம்ம இந்த டெரிவேஷனே பண்ணியிருந்தோம், சிங்கிள் ஸ்டேஜ் கால்குலேஷனுக்கு வந்து டெரிவேஷனே பண்ணியிருந்தோம். அதுலேயே நம்ம ஒன்று சொல்லணும், 100% சிங்கிள் ஸ்டேஜ் அச்சீவ் பண்ண முடியாது. ஸோ சிங்கிள் ஸ்டேஜ் வந்து இம்ப்ரூவ் பண்ணோம்னா மெத்தட்ஸ் ஆஃப் இம்ப்ரூவ்மெண்ட் இன் சிங்கிள் ஸ்டேஜ் என்ன பண்ணோம், increase the length of the cross arm or different grading of the disc. Next என்ன பண்ணோம், but using the guard rail இதெல்லாம் டிஸ்கஸ் பண்ணினோமா மெத்தட்ஸ் ஆஃப் இம்ப்ரூவ்மெண்ட் இன் தி ஸ்ட்ரிங் எஃபிஷியன்சி. ஸோ இப்போ இங்கே 1/8 என்னது, கே வேல்யூ வில் பி ஈக்குவல் டு ஆஃபன் 1/8. அப்படின்னா என்னது, கே வேல்யூ இஸ் கோயிங் டு ஆஃபன் 0.125. 0.125 அதுதான் வந்து கே வேல்யூ வந்துடும். இப்போ கே வேல்யூ வந்து பார்த்தீங்கன்னா 1/8னா தட் இஸ் கோயிங் டு ஆஃபன் 1/8. 1/8னா என்ன வரும், பட் கே வேல்யூ இஸ் கோயிங் டு ஆஃபன் 1/8. இட் மீன்ஸ் assuming the sun capacitance between each insulator is going to have 1 and the earth is 1/8 of the capacitance value. 1/8 of the capacitance value, K value will be equal to 1. It means if C is the self capacitance identity, then your Kc will be of your sun capacitance. Okay, அப்போ K ஓட வேல்யூ என்னது 1/8. It means 0.125. ஸோ அப்போ அந்த இடத்துல வேல்யூ வந்து பார்த்தீங்கன்னா 0.125 ஆயிரும் K ஓட வேல்யூ. ஓகேவா? ஸோ இப்போ இங்கே என்ன கொடுத்துருக்காங்கன்னா voltage across the line unit is going to happen 17.5 voltage. 17.5 voltage. அப்ப என்னன்னா V3 ஓட வோல்டேஜ் கொடுத்துட்டாங்கன்னு அர்த்தம். V3 வோல்டேஜ் வந்து கொடுத்துட்டாங்க. இந்த மாதிரி V3 வோல்டேஜ் வந்து பாத்தீங்கன்னா இந்த V3 டிஸ்கோட வோல்டேஜ் வந்து பாத்தீங்கன்னா 17.5 கிலோ வோல்ட். அப்ப நீங்க என்ன பண்ணணும், V2வும் V1ம் கால்குலேட் பண்ணணும். எப்படி, அட் நோட் A அண்ட் நோட் B ல entering current is equal to open leaving current. அதை வச்சு தான் you can able to calculate what about your line current. இந்த கொஸ்டின் இந்த மாதிரி டைப் ஆஃப் ப்ராப்ளம் நம்மளது வந்து அனலிட்டிக்கல் சப்ஜெக்ட். ஸோ அப்போ இந்த மாதிரி ஒரு ப்ராப்ளம் என்ன பண்ணுவாங்கன்னா, இந்த மாதிரி ஒரே கொஸ்டினை கேட்காம ப்ராப்ளத்தை கொடுத்துருவாங்க. ஃபர்ஸ்ட் கொஸ்டின்ல ப்ராப்ளத்தை கொடுத்துருவாங்க, ரைட்டா? ஃபர்ஸ்ட் கொஸ்டின்ல ப்ராப்ளத்தை கொடுத்துருவாங்க. வித் தட் சேம் கொஸ்டின் தே ஆஸ்க் டு கால்குலேட் வாட் இஸ் தி V1 வோல்டேஜ். இட் மீன்ஸ் வாட் இஸ் த வோல்டேஜ் அக்ராஸ் தி டாப் யூனிட். இதுதான் வந்து டாப் யூனிட், இது மிடில் யூனிட். This is going to occur V2 வந்து மிடில் யூனிட், இது வந்து நியரஸ்ட் தி கண்டக்டர். ஓகேங்களா? ஸோ V1 வோல்டேஜ் கால்குலேட் பண்ணுங்க, V2 வோல்டேஜ் கால்குலேட் பண்ணுங்க, வாட் இஸ் V3 வோல்டேஜ். அப்போ ஒரே ப்ராப்ளத்துல 3 கொஸ்டின் இருக்கும். இப்போ வோல்டேஜ் கால்குலேட் பண்ண என்ன பண்ணா, ஸ்ட்ரிங் எஃபிஷியன்சி கால்குலேட் பண்ண முடியும். ஸோ அப்போ 4வது கொஸ்டின் என்னது, ஸ்ட்ரிங் எஃபிஷியன்சி. ஸோ அப்போ இந்த ஒரு ப்ராப்ளம் சால்வ் பண்ணீங்கன்னா 4 கொஸ்டினை வந்து யூ கேன் ஏபிள் டு ஆன்சர். யூ கேன் ஏபிள் டு ஆன்சர் தி 4 கொஸ்டின். யூ கேன் ஏபிள் டு ஆன்சர் தி 4 கொஸ்டின். இங்க நான் வந்து ஒரே கொஸ்டினா கொடுத்துருக்கேன். நீங்க சால்வ் பண்ற ஸ்டெப் பை ஸ்டெப் எப்படி நீங்க வந்து நார்மலா வந்து நம்ம ஒரு ப்ராப்ளம் கொடுத்து நம்ம தியரிட்டிக்கல் கிளாஸ் சால்வ் பண்றோமோ அதே மெத்தடாலஜி நீங்க சால்வ் பண்ணிட்டு வரணும். சால்வ் பண்ணிட்டு வரப்போ பாத்தீங்கன்னா ஸ்டெப் பை ஸ்டெப் வேல்யூ கிடைக்கும். அந்த ஸ்டெப் பை ஸ்டெப்ல வந்து பாத்தீங்கன்னா they will ask questions like NPTEL, if you solved some of the problems in NPTEL, they will give the data in the first question, and second, third, fourth questions will be with respect to the data of the first question. Same type you will have in your MCQ. Are you able to get it? புரிஞ்சுதாப்பா? Chrome tab தெரியுதாப்பா? Whether you can able to see the Chrome tab?
Yes, sir.
நம்ம கிளாஸ்ல இந்த ப்ராப்ளம் போட்டிருக்கோமா இல்லையா? இந்த ப்ராப்ளம் போட்டிருக்கோமா இல்லையா கிளாஸ்ல? இந்த கொஸ்டின் குறித்து இந்த ப்ராப்ளம் போட்டிருக்கோமா இல்லையாப்பா?
சார் ஒரு நிமிஷம் சார் செக் பண்ணிட்டு சொல்றேன்.
இப்படிதான் கொஸ்டின் கொடுத்துருப்பாங்க. இதுல வந்து ஃபர்ஸ்ட் நம்ம கே வேல்யூ கால்குலேட் பண்ணுவோம். கே கால்குலேட் பண்ணிட்டு வோல்டேஜ் அட் ஸ்ட்ரிங் வந்து பாத்தீங்கன்னா வில் கால்குலேட் தி given voltage 33 kV கொடுத்தனால வோல்டேஜ் அக்ராஸ் ஸ்ட்ரிங் வந்து பாத்தீங்கன்னா 33/√3 is going to find. Then node A applying Kirchhoff's current law. What is the equation now? So we will get the relationship. Similarly at junction B. So what is the relationship? So voltage at the whole string will be equal to 1. If you add V1 plus V2 plus V3, that is going to have the whole voltage. That is equal to 1. So whole string or voltage வந்து எவ்வளவு கொடுத்திருந்தாங்க? 33 வந்து divided by √3 போட்டீங்கன்னா 19.05. So 19.05 போட்டீங்கன்னா what is the voltage in this thing? So top unit எவ்வளவு voltage, middle unit எவ்வளவு voltage, bottom unit எவ்வளவு voltage. இது கால்குலேட் பண்ணா you can able to calculate the string efficiency, voltage across the string divided by number of insulator into V3. So you get this string efficiency. So அப்போ பார்த்தீங்கன்னா ஒரு ப்ராப்ளம் கேட்டேன்னா 1 2 3 4. So subsequently you can answer for 4 multiple choice questions. அப்படிதான் இருக்கும். Subsequently you can able to answer for your 4 multiple choice of questions. இந்த சம் சால்வ் பண்ணிருக்கோமா இல்லையா?
Yes, sir.
தெரியலனா போயிட்டு பாருங்க. கூகுள் கிளாஸ் ரூம்ல டிவிஷன்ல வந்து பாத்தீங்கன்னா பார்ட்ல வந்து பாத்தீங்கன்னா 2 வீடியோ அப்லோட் பண்ணிருக்கேன். ஒன்னு வந்து பாத்தீங்கன்னா இது ஈஸி ஆஃப் தியரிட்டிக்கல் கான்செப்ட் எக்ஸ்பிளைன் பண்ணிருக்கேன். செகண்ட் வீடியோ பட் we solved the numerical problem. எப்ப சால்வ் பண்ணிருக்கோம்? 24th அக்டோபர் வந்து இந்த ப்ராப்ளம் வந்து சால்வ் பண்ணிருக்கோம். ஸோ அதனால இப்போ மாடியூல் 3 வந்து பார்த்தீங்கன்னா இன்சுலேட்டர் இருக்குது, அண்டர் கிரவுண்ட் கேபிள்ஸ் இருக்குது, டிஸ்ட்ரிபியூஷன் சிஸ்டம் இருக்குது. டிஸ்ட்ரிபியூஷன் சிஸ்டம் பார்த்தீங்கன்னா ஏசி டிஸ்ட்ரிபியூஷன், டிசி டிஸ்ட்ரிபியூஷன் இருக்குது. இதில் எல்லாமே வந்து பார்த்தீங்கன்னா நியூமெரிக்கல் ப்ராப்ளம்ஸ் இருக்குது. ஸோ அப்போ பார்த்தீங்கன்னா they will ask a single question. With the single question you have to answer for the subsequent multiple choice. ஸோ அப்போ வந்து பார்த்தீங்கன்னா when you are sitting for your exam, okay, keep ready with your paper and your calculator. You have to work it out, then you have to answer for the subsequent questions. நீங்க ஒர்க் அவுட் பண்ணாம நீங்க பண்ண முடியாது. Got it? புரியுதாப்பா? So that's why we'll have of nothing but UT3 will be there, which will be based on this type of questions will be there. Okay, so prepare it. So try to solve that one so that you can able to get practice, you can able to get good mark in your CA3 and your income examination. Okay. So those who are not submitted, submit your assignment. So if I enter 0 marks, the marks cannot be altered. Okay. Thank you. We'll see you in the next session.